11.2 is on parabolas, but we've already talked about parabolas in chapter 8. So these are the parabolas that we haven't really talked about in chapter 8, and they are the other type of conic where your parabola is going to be opening up to the right or to the left rather than up and down. So in the past, we had y equals a x minus h squared plus k, where the vertex is hk, again, opposite of the part that's in the parentheses associated with the x, and then keep the k as it is because that's how y is being affected. And if your A is positive, it'll open up. If it's negative, it'll open down. If your A is greater than 1, it'll be stretched in comparison to the parent graph. If it is 1, it is the same shape as your parent graph. If it's less than 1 as an absolute value, it'll be wider than the parent graph. If it's 0, it's actually not a parabola, it'll be a line. And then as it gets negative, again, it's wider but downward. And then if it's even more negative, more than -1, then it's skinnier but opening down. So you can go back to the chapter 8 lesson on parabolas if you want to review that a little bit more, but the rules for the parabolas to open right and left are very similar, except for you're going right and left rather than up and down. So it's basically the inverse of this. Your x and y have switched places. And when we took an inverse in section 9.2, when we switch x and y, we normally solve for y. And if we were to do that here, you'd subtract h, you divide by a, you take the square root, so you'd have plus or minus the square root, and then you'd add the k. The point I'm trying to make is, in order to undo the squaring, you'd end up taking a square root, so you'd have positive square root shape like this, and the negative square root shape like that. And so essentially, this is the positive and negative square root, but written where it's not involving a square root. So it's solved for x rather than for y. But what you can do is recognize that, oh, this is a format that is got the y being squared and the x is not. That is a parabola, but it's the kind that's opening up sideways. Another note that I want to kind of really alert you to is that because HK, it's the same HK for your vertex, because your H is associated with your X, it is now this one is the H, and the K is associated with your Y, the K is associated with a Y. So when you do your vertex, it's H then K versus HK. So those also switch their location for the H and the K, so just be careful. Again, opposite for what's in the parentheses, keep what's not in parentheses as it is. Okay, and I already talked about the A being the same, but sideways. Okay, so here we have x equals, so we know it's a parabola, it's opening up to the side. Since the A is an invisible 1, it's going to be opening up to the right. Your vertex will be at -10, +3. Because your A is 1, it's just the normal shape, and we're just opening up sideways. So 1 times A, so 1 times 1, and then 1, and then 2 would be 4, and 3 would be 9. You're just doing squares, because again, you're squaring. That's your function for parabolas. Here, you are given the vertex and the y-intercepts, and you're asked to write the equation. So we would graph those and we'd go, oh, look at this. The distance here when I go up 1 is that I'm going over 1, but I'm going to the left. So my A will be -1 because I'm going left, and 1 because it's 1, and then it's 1 times A, and we went 1, so the A must be 1. But negative because it's going to the left. And then you could write your equation as x, because it's opening up right or left, equals the A, which is -1, y minus your k, so hk, so -2 squared, plus your h, which is 1. So the vertex is always HK, but the position is backwards from what you are used to from your parabolas that open up and down. So here's another one where we write the equation. We've got the vertex given to us and the y-intercepts again. But this is to really show you about right and left and the value of A. So this is really more about A and just practicing writing the equation. So it is a right-left opening up, because if this is the vertex and it goes through these 2 points, it cannot be up or down because you wouldn't be able to go through both those. So we know it's opening up to the right in order for these 3 points to be lying on your parabola. So if I go 1 unit away, I'm going up 3, or to the right, I should say, right 3. So that means that I'm going to the right, so it's positive and 3. And then again, HK, so the H is this part, the K is that part. So again, it kind of reverses its position when you put it in the equation, because this belongs with the Y, so 2. This belongs with the X, so it's -3. So here it's saying when the X term is the one being squared, it opens up or down. When the Y term is being squared, it's right or left. So this is exactly what we had at the beginning of the lesson I mentioned. Here when it's Y equals and the X is being squared, it is the up or down case that we had back in chapter 8. Here when it's the Y that's being squared, then it is the right or left case. But again, HK, H is just our different positions. HK is the vertex in either way. So in order to write a parabola in like standard form, you will, in this case, want to solve for y, and in this case, you're going to want to solve for x. So we see here we have the y is a squared one, so we're going to solve for x, because here the y is squared, so we're going to solve for x. So to solve for x, we subtract y squared from both sides. We divide by -2. And then we can simplify that to positive 1/2, 1/2 y squared. And there we go. Our A will be 1/2. Our center will be 0, 0, because nothing is here or out here, as you can see. So 0, 0, H, K. So I plot my 0, 0. It's a positive A of 1/2. So I go up 1 and over 1/2. Normally I'd go up 1 and over 1 if the A was 1, but I'm going to go half of that. Up 2, normally it's 4, because 2 squared is 4, but I'm going to go half of that, so I'm only going to go 2. And you can see, especially if I zoom in a little bit more, that I'm always doing 1 times A, then 4 times A, then it would be 9 times A, 16 times A. Whether I'm going up, down, right, left, that is the pattern of the relationship between your going over and up, or over and down, up and right, or up and left, or and again, they're always symmetric about the vertex. Parabolas are always symmetric about the vertex. All right, so a couple more. Here it's asking you again to write this one in standard form and to graph it. So I have y being squared. My x is not, so I want to solve for x. So I'm going to get rid of this fraction, and I'm going to get rid of the negative. So I'll do -3 to each of these. I'm not going to expand it because it is helpful to have it in that vertex form. We do want it in the vertex form. Not the standard form, because it makes it easier to graph. Sorry, the standard form, not the general form. So I call it vertex form. So we're going to then add 5 to get the x by itself. And so there we go. That's the equation. And you could put the x first. It just makes it a little more comfortable maybe for the equation. And A, there's the H and then the K. Because it's the X case, this is going with the Y, so that's the K. And this is belonging to the X, so it's the H. So I'm going to plot that HK. So I'm going to plot 2 as my Y coordinate and 5 as my X. So the vertex is 5, 2. Then the A is -3. So I'm going to go to 5, 2. I'm going to go to the left because it's negative, and I'm going to triple my distance of the parent. So instead of 1, 1, it's going to be 1, 3 to the left because of the negative. And instead of 2, 4, it's going to be triple that. So it'll be 2 and then 12. Again, always from the vertex. And same going on the other side. Lastly, here's an example. I changed it from a 7 to being a 6 and then realized it had to be a 7 to work out nicely. So let's call that a 7 there. So we have this equation here, and we're trying to write it in standard form. So we want to have it have squared thing as a perfect square. So what I notice here is I only have a y squared. There's no x squareds. So I know it's a parabola, and I know that it's going to be one of the ones that open right or left. So I'll need to solve for x eventually, but first off, let's get the y's together and make that its perfect square. So half squared, so -1 squared would be +1. What you do to one side, you do to the other. Notice I got the x already on this side. You can do that now or on a future step, but you are going to want to solve for x. So get on that side. And I like having the constants not on the side where I'm completing the square. That's personal preference. You could add 1 and subtract 1 and keep the 7 on this side. It just gets a little bit cumbersome to me. I much prefer what I do to one side, I do to another side of an equation instead of doing and undoing all on one side. So I put the constant and the x term because I'm solving for x. And again, you could do that later if it makes more sense for you to do it later. So this is the perfect square of y minus 1 squared. Again, we're trying to solve for x, so we're going to add 6 to both sides, and then we're going to divide by -6 and divide by both things. So this is going to be 1 over -6, so -1/6 of the y minus 1, and then 6 divided by -6 is -1 equals x. So let me show you some of the homework questions associated with this lesson and the tool to use it. So, all right, so here is the 11.2 homework assignment. You can see it's x equals, so, and it's something squared, so it's a parabola. It's going to be opening up either right or left. Because the a is positive, it's going to be opening up right. Because it's 4, it's more than 1, it's going to be stretched, it's going to be very narrow, and all your distances will be multiplied from the parent graph of 1, 1, 2, 4, 3, 9 by 4. And your vertex will be at -1, 2. So you are going to pick the one that's going out to the side and instead of the up-down one, and you're going to go again to -1, 2. Okay, you do the same value as here, but then you always do the opposite of what's showing here. So, and then we're going to be going to the right because it's positive. And 1 would normally be 1, but we're going to multiply that by 4. So we're going to go out 4. 2 would normally be 4. We would multiply that by 4 and go out 16. So you'd have to go way out here, and you can visualize that that is going to match up with that. But again, you can't plot it. And all you need is 2 points, the vertex and one other point on the line. So the easiest way to do it is plot your vertex, go 1 up, and your a value, because it's always 1 times a, so it's always your a. Either right, left, up, or down, depending on what type of parabola you have. So the next one is very similar to that. It is negative, so it will be going to the left. It is -1, so it'll be that normal 1, 1, 2, 4, 3, 9 from the vertex. Again, only plot your vertex and one other point when you're using the tool. And make sure you select the correct tool. The next two, you have to first complete the square. This one is y equals. So this is, and the x is being squared, so this is the regular up-down parabola that you're used to. So make sure you select this one and go up or down. In this case, it will be a +1. You'll have to find the vertex. You can do that by either completing the square and putting it in vertex form, or by finding the vertex using the vertex formula, x equals -b/2a, and then plugging that in for the x to find the corresponding y, and then using the a of 1. You can also do a t-table if you are not as comfortable. The only thing is you'd have to make sure you end up getting your U shape, that you find the vertex and have points on both sides. Again, only the vertex and one other point when you're doing your parabola. And this one, it doesn't even have the parabola, opens right left, so you kind of are, by the nature of the question, gonna know it has to be the up-down situation. Okay, this one's x equals and the y squared. So this is the right-left parabola because, again, you only have one thing squared, unlike the circles where you'd have an x squared and a y squared term. I would recommend that you watch the video on completing the square back in chapter 8. Again, if you need help, I will see if I can't do a little bit of notes on that right now, though. All right, so you would, or I would, add 14 to the left side and the right side, and I would factor out my a because I want my a out in front anyways. So I'm not factoring this, I'm just factoring out the a only. So that would leave me with y squared, and because I factor out a negative and I have a positive here, it has to be -3 times 4 would make that 12. Okay, so I'm going to go ahead and write plus blank here because I'm going to try to complete the square, make this a perfect square, which means I'm also going to have to add something to this side. So when I complete the square, I'm going to take half of the b, half of the thing I'm completing the square of, and because we always factor out the a, it's always going to be a 1, and so you can go ahead and complete the square when your a is 1. So for this, when we complete the square, half would be -2 square it, you get 4. But what you've added to this side of the equation really is -12. So you'll have to add -12 to this side. So you end up getting, for the next line, x plus 2 equals -3 y minus 2 squared. And we want to get x by itself, so we'll subtract 2 from both sides. And so there it is. The vertex would be -2, comma, oops, sorry, I did not mean to put a little squiggly on that last one. It's just exactly what it is. So -2 and then opposite, so 2. And your a is -3. And again, this is opening sideways. And because the a is negative, it's going to be opening left, and it's going to be stretched by a factor of 3. So if I were to graph this, I'd pick the sideways parabola. I'd go to -2, 2. I would go to the left because the a was negative, and instead of 1, 1, it's going to be 3 times that, so 1, 3. Again, this always corresponds to your a. And that's that. I hope that helps with your lesson on parabolas, the sideways type in particular, 11.2.